Hello everyone, welcome back to my YouTube channel. Today we are discussing weekly contest 387. I was able to solve the first three questions. We are going to discuss the third one now. So we have to find out the minimum operations to write the letter Y on a grid. We are given a zero indexed grid, n into n size, and n would be odd. And the grid RC can contain 0, 1 or 2, either of these three. We say that a cell belongs to letter Y if it belongs to the diagonal starting at the top left cell and ending at the center cell, or starting at the top right and ending at the center, or the vertical line starting at the center cell and entering at the border of the grid. The letter Y is written on the grid if and only if all the values at cells belonging to the Y are equal, all values at cell not belonging to Y are equal, and these two values should not be equal to each other. So we need to find out the minimum number of operations needed to write the letter Y on the grid, given that in one operation you can change the value to any cell to 0, 1 or 2. So before this, let's just analyze this grid. So let's take our n as equal to 5. So we have this grid, and this orange colored one forms the Y path. So as you can see, what our analysis or intuition here should be, like, first we can find out, or we can keep track of the zeros, ones and twos that come in the Y path, this orange one, and in the non-Y path, this black one. So for the Y path, we can directly see for this top left to the center, top right to the center, and center to the bottom. We can see this I is equal to j, and we need to travel. We need to like make this pattern that I is equal to j, and only till I is less than equal to n by 2. So we can traverse this. And for this one, we can just see I plus j is equal to n minus 1, I plus j equal to n minus 1, and I is greater than equal to j. I is less than equal to j. Sorry, yeah. So we'll get this part. And for this one, we can directly see that j, that is our column, is equal to n by 2, and I is greater than equal to j. So we'll get this. So I'll just show you how we can keep track of the zeros and ones. And not only for the Y path, also for the non-Y path, we need to keep track of zeros and ones. So I've taken one array of 3 size just to take 0, 1 and 2, and taken another array of 3 size for 0, 1 and 2 for the non-Y path, and this one is for the Y path. Now I'll also take total number of elements in Y and total number of elements in non-Y path. Yeah. So I'll just loop over it from I0 to n, j0 to n, and this is for the top left to the center. This is for the top right to the center, and this is for the center to the bottom, this condition. So that means this comes in the Y path. I'll just increment the counter of 0, 1 or 2, whatever it is, and I'll also do total Y count. Otherwise I'll put it into non-Y path. Now uh, once we get this, suppose this is our actual grid, this one, and now I've got the Y path and non-Y path. So you can see in my Y path I've got 2 zeros, 2 ones and 3 twos, and in my non-Y path I've got 3 zeros, 4 ones and 11 twos. So now the best ideal case in such a case would be like, I can take the highest counter, like it is 3 here, and I can convert the rest to 2. That would be easy. Like if I take convert everyone to 2 here, that would cost me 4, 2 plus 2, and that would be the minimum cost. If I start to convert every element of Y part to 0, then it would cost me like 2 plus 3, 5. So let's just take 2. And from the non-Y path also, the best part would be if I convert everyone to 2. That would just cost me 7, as we have got 11 twos already. So this is how we need to approach it. But the main problem here, there's still one edge case, that is we can't have the same element in the Y path and in the non-Y path. As in this case, we have got the highest element 2, highest element 2 in both y path and non-y path. If the condition is like that, suppose I've got this one as 1 and this one as 4. In such a case, I can convert everyone to 4 here and everyone to 2 here. In such a case, that would be easy. I can just do total elements in y minus 1s, total elements in non-y minus 2. That would give me the right solution. But in case we have got the equal, we have got the highest element as equal, then what we need to do? So for that, what we need to say is we'll find the cost of converting in y also and non-y also to the highest one. Suppose the cost here is just 4 and the cost here is just 7. So what we can do is, one way is I convert y path to all 2's and non-y path to all 1's. That is my second highest. And one more would be that I convert all my y's to 1's and all my not y path to 2's. Now these are the two conditions. So one is I convert my y to the highest one and not y to the second highest one. And in the other cases, I convert my y to the second highest one and not y to the highest one. Now I need to calculate the cost in both and I need to take the minimum one. Suppose I take this. So in this my cost would be around, if I'm converting everyone to 2, so it would be for y path it would be 4 coming from y path, and if I'm converting not y all to 4, so it would cost me 3 plus 11 14 for non-y path. So total cost is 18. Now in this case, if you see, my cost would be, if I'm converting all the elements in y part to 1 I'm converting, so zeros would be converted, 2's would be converted, it would just take me 5. Now in case of non-y, I'm converting everyone to 2, so it would just take me 4 plus 3 7. So this would give me total of 12. So this is an efficient one, so we should go for this one. So after calculating the counts of zeros, ones and twos in both y path and non-y path, what we need to do is we need to find the highest element and its frequency and second highest element and its frequency both in the y path and in the non-y path. This can be a bit optimized. I've written this in a very naive approach. You can check this out yourself as well. So once we have got the highest element and second highest element of both y and non-y path and their frequencies, if the highest of y and non-y are not same, then we can directly convert both y path and non-y path to their highest and directly return this, the cost. If these are same, in that case, one is, as I've showed, one case is I take the highest in y, other is I take the highest in non-y. So I take the highest in y path like this and second highest in not y. One is I take the second highest in my y path and the highest in my non-y path, and then I take the minimum cost and I return it. Yeah, so that's it. You can let me know if there's any question in the comments. Thank you.